Welcome to checkpoint 9. I have my notes up it's titled the Unit 2 Review Theorems, so I'm going to be modeling how I would use those notes if I were a student to help me answer these questions so that you have an idea and a demonstration of how they can be used, as well as asking certain questions that you may have. So here we go. Question 1. Use the triangles to answer the question. Can the SAS congruence postulate be used to prove the triangles are congruent? So we have yes, because the triangle ABC is congruent to triangle DEF by SAS congruence postulate. No, there's not enough information to use this SAS congruence postulate to prove the triangles are congruent. Or yes, because triangle ABC is congruent to triangle FED by this SAS congruence postulate. So one question may be, what is the SAS congruence postulate, and is that really how I say it? So if I scan over here, I'm seeing SAS, side angle, side. Okay, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. So what is an included angle? And so if we scan again, we see included angle right here in the left corner, and it's an angle between any two adjacent sides of a polygon. So if I'm looking, side AB and side BC are adjacent, and this means that angle B is our included angle. So whichever sides are the sides of the angle are, that's what they're talking about, this included angle right there. So we need to find an angle with the same measurement and the same measurements of their sides, their adjacent sides. So if we look at triangle ABC, A corresponds to D. So angle A corresponds to angle D. So right now if I look, angle A is going to correspond to angle D. And if we look right now, we can see that the angle of A is 72.4 degrees and angle D is 72.4 degrees. Okay, well that's our angle, and now if we want to look at the sides, we're going to look at the side that those two sides that the angle touches. So we're going to look at AC, and there's not a measurement there, and that corresponding side would be for FD, and there's not a measure there. So I can't determine if those sides are the same length, so I can't use angle A and its corresponding angle D for the side angle side. We can move on to the next corresponding angle, which would be angle B and angle E. So angle B is corresponding angle in the other triangle, and corresponding means the same angle, just in the other shape. So angle E, and notice that angle B is 33.9 degrees and angle E is 33.9 degrees. So then I'm going to look at the sides that this angle touches. Those are the adjacent sides. So from B to A is 5.9, and the corresponding side, since A's corresponding vertex would be D, the corresponding side for in this triangle would be ED, which is 5.9. So far we have one side, the angle, and now we need to check the other adjacent side of the angle. So we have B to C is 5.8, and now C's corresponding vertex would be F, so we need to check the side length EF because that's the corresponding side length to BC. So EF is 5.8, so we have the side, an angle, and the side. We have the corresponding side, the corresponding angle, and the other corresponding side. So we have side, angle, side. So yes, triangle ABC is congruent to triangle EDF by the side, angle, side congruence postulate. So now one question you might have is, can I use any vertex and the two sides that are touching that angle to check for side, angle, side? And the answer is yes. Any of these vertices we could have checked, just like we started with angle A and its corresponding angle D, and it didn't work. So then we moved on to the vertex, the angle B, to check, and its corresponding angle was angle E, and that one did work. Now if it didn't, we could have moved on to angle C and its corresponding angle F to check. So, and if none of those angles had the adjacent sides to it that were congruent, then it would have been a no. Okay, question 2. Use the information diagram and proof to answer the question. Given AC, segment AC is given the distance of AC is equal to the distance of AE, and the distance of AB is equal to the distance of AD, prove that triangle ABC is congruent to triangle ADE. Okay, so what is this saying? Let's mark our diagram. So we have that AC, the distance of AC, so I'm going to use a tick mark, is equal to the distance of AE, which they are labeled 3 and 3. So they're equal. And then the distance of AB, and I'm using 2 tick marks because we're talking about different distances, is equal to the distance of AD, which is also true. They're both measured as 3.6. Now we have to prove that triangle ABC is congruent to triangle ADE. So I'm looking at this proof. It says AC is equal to AE and AB is equal to AD. Given. Yes, that was all right here. Now it says a line segment AC is then congruent to line segment AE, and line segment AB is congruent to line segment AD. And the reason is left blank, so we need to fill in that reason. And we have the options here that say X. Is it given that they're congruent? Is it the transitive property of congruence? Or is it the definition of congruent segments? So if I'm scanning and we want to talk about reflexive properties, I'm looking for properties of incongruence. So the reflexive property of congruence says a geometric figure is congruent to itself. Well, we weren't talking about geometric figures, so it's not going to be the transitive property of congruence. X, was it given? No, it was given that the distance, the length of those sides were the same, but it wasn't given that the segments were congruent. So then the last option is definition of congruent segments, and let's scan to see if we can find congruent definition for a congruent segment. So I'm just looking in the left-hand column for congruent segments. Okay, I see congruent. And it says align segments are congruent if and only if they have the same length. Okay, that's the definition of our congruent segments. They had the same length. So then we move on to statement 3. It is saying that angle BAC and angle DAE are vertical angles. So what angle is that? Just so we can have it in our head. So we follow the order that those points are listed out. So B to A to C. And if you notice that our angle is formed at angle A. So this angle, they're saying, is congruent to D to A to E, and it's right here. So they're saying these two angles are congruent, that are vertical angles, and it's the definition of vertical angles. So then it says angle BAC is congruent to angle DAE, and Y is left, and it's left blank. So what are our options for Y? The definition of congruent angles, the reflexive property of congruence, or the vertical angle theorem. So we need to scan for congruent angles. Angles are congruent if and only if they have the same angle measure. Okay, let's look for the reflexive property of congruence, and that was in our congruent properties. And that's if a geometric figure is congruent to itself, so no. Or it's the vertical angle theorem. So let's scan for vertical angles. Okay, I'm scanning and I don't see vertical angle theorem right now, but I will be adding that so that it is included in the notes. Bisector, side angle side. Okay, so we need to, I'll add that to the notes so you have it. And right now it is going to be the vertical angle theorem, and one of the reasons that I can say that without having the definition of the vertical angle theorem is I'm looking at this example proof of the side angle side congruence of a congruence, and I'm looking through their reasons, and I see right at step 7 it has angle DAE and angle BAC are vertical angles, definition of vertical angles. And then the next statement is that angle DAE is congruent to angle BAC, and the reason is vertical angle theorem, which is set up exactly like our statements and reasons. Statement 3 is angle BAC and angle DAE are vertical angles. So that's set up just like statement 7 in the example. And the reason is definition of vertical angles, which is the exact same definition the exact same reason as ours. And then if we move to step 4, it's the exact same jump. They both went from stating the vertical angles to stating that the angles were congruent, and the reason was a vertical angle theorem. So even though I did not have the vertical angle theorem in these notes right now, I can, by using the example proof, with surety know that the reason is the vertical angle theorem because I was comparing those two steps that are set up the same in our proof. So that's one way we can use example proofs to help us answer the questions about the proofs that we're giving, is to find statements and the reasons that are set up exactly like the statement and reason in the new question. So we have that, and we're going to move on to question 3. Use the triangles to answer the question. Trinity states that the side angle side congruence postulate can be used to prove the triangles are congruent. Is Trinity correct? Why? Blank, the triangles have blank labeled with equal measures, so blank. Select 3 answer choices that fill in the blanks in the previous sentence to make it a true statement. Select 1 answer choice for each blank, A, B, and C. So A's options are a yes or a no. So let's first decide, do they have a side angle side? So I'm noticing first the angle. So they have this angle that is 63.4 degrees, and in this triangle it has the angle 63.4 degrees. Now we need to know if the two sides of that angle are the same. So I'm going to be looking, this side is 1 and this side of the corresponding angle is 1. So far we have one side, the angle, and one side and the angle. So now we just need to verify the last side. So the other side of this angle, that side length is 2.2, and so the other side of the angle needs to be 2.2, and it is. So we do have a side angle side congruence postulate. So A is going to be yes. The triangles have blank labeled with equal measures. So blank. Okay, so B, 3 pairs of corresponding sides, or 2 pairs of corresponding sides and the included angles, or 2 pairs of corresponding sides but no included angles. Well, for the side angle side, we have to have the included angle. So 2 pairs of corresponding sides. We had the 1 pair, and then we had the pair that was 2.2 in length. And then the included angle, which was 63.4 degrees. So C, the triangles can be proved to be congruent using the side angle side congruence postulate. Question 4, use the triangles to answer the question. Which of these statements about the two triangles is true? The two triangles cannot be proved congruent by using the side angle side congruence postulate because the measure of all corresponding sides and angles are not given. Okay, for side angle side, we only need 2 corresponding sides and 1 included angle. So we don't need all of the corresponding sides. So that one we're not going to consider because we only need 2 corresponding sides to know, and not all of them. So the next one, the two triangles can be proved congruent by using the side angle side congruence postulate because the triangles have the same shape. No, we need to have 2 sides and the included angle. The two triangles can be proved congruent by using side-angle-side congruence postulate because the measures of two corresponding sides and one pair of corresponding angles are equal. Okay, let's see. Do we have two corresponding sides? Alright, so we have 1.5 right here, and its corresponding side is 1.5. Okay, there's one pair, so the next pair of corresponding sides would be the 3.6 and the 3.6. So far we have two pairs of corresponding sides, and we need one pair of corresponding angles. Well, what is the angle that we have to use when we use side angle side? It has to be that included angle. It has to be the angle that these sides are the angle sides. So if I drew from 1.5 to 3.6, the side that's measured 1.5 and the side that's measured 3.6, this angle right here is the angle that has to be marked to be congruent. And so if I compare it to the angle, if I drew from the side that measured 1.5 to the side that measured 3.6, our corresponding sides, this included angle right here is not measured, is not given a measure. So I can't say it's congruent because it's not given. So this one I can't say because the one pair of corresponding angles are equal. That's not given. The included angle isn't given. Even though this 25° right here is given, I can't use it because it's not the included angle. So then the two triangles cannot be proved congruent by using side angle side congruence postulate because the measures of the included angles are not given. Yes, that is our answer. So it has to be the included angle that we are using. I want to go through question 6 and then give you I'll give you the help tip. Right now it's called smoothing behind the ears, and you would do this to reduce your fear and anxiety, and it releases tension. So what you do is you take your fingers and you just bring them to your temples, breathe, and you bring them behind your ears and down your neck. And you just breathe. And a lot of us do this naturally when we're stressed. You take your fingers and you just run it through your hair and pull it out the back. And there's a reason, and it's because it reduces our tension in our bodies. And so it's actually the technique's called smoothing behind the ears. So you just run your fingers behind your ears and you breathe as you bring it down by your neck. And so that's your technique that you could use if you were feeling tension or anxious, is just to run your hands back down along your ears and down to your neck and just breathe for a minute, and then you've regained your composure, release some anxiety, and then now we can go back to what we were doing. So I will end with question 6 since it is a proof, and I want to step through that. So given that segment AB is congruent to AD, C is the midpoint of BD, and measure of angle ACB is equal to 90 degrees, and the angle is ACD is a right angle. Prove triangle ABC is congruent to triangle ADC. So the first thing that I'm going to do is I'm going to scan these example proofs to see if one of them is set up similar. And I'm scanning and I noticed right here it says given AB is equal to 3.1 and AD is equal to 3.1. Those are given that those two segments are equal in length, so they're congruent. And we are given that two segments are congruent. We are also given a midpoint, and this one is also given a midpoint, but we're given more. We're given that the measure of this angle ACB is 90 degrees. We're given that this one is 90 degrees, and we're given that ACD is 90 degrees, is a right angle as well. So I'm going to be using this proof because it has the midpoint and the two sides that are congruent. So AB is congruent to AD. That means that this side is congruent to this side. So I'm going to mark that. Now we're going to read through our proof. And it says AB is congruent to AD. That's given. Angle ACD is a right angle. Given. Measure of angle ACD is equal to 90 degrees. That's the definition of a right angle. Then it's stating that the measure of angle ACB is equal to 90 degrees. That was given. That was given right here. And then they're saying the measure of angle ACB, they're saying that this angle is equal to the measure of angle ACD, this angle right here. And they're saying it's the transitive property of equality. The reason why they can say that is because both of those angles equals 90 degrees. So they would have set it up as, what's the linking point? This is how I think of the transitive property. What's my linking point? So we have ACD is equal to 90 degrees, and 90 degrees is also equal to angle ACB. So our linking point is that they're both equal to each other. So can we cut out that middleman? Yes, because they're both 90 degrees, and so we can just say ACD is equal to ACB. So the transitive property of equality is, I view it as the middleman property because they both equal to 90 degrees. So 90 degrees is my middleman in this example. So then statement 6, angle ACB is congruent to angle ACD, definition of congruent angles. Then C is the midpoint of BD, given. C bisects BD, and what is that blank? That's what we need to fill in. So I'm going to look at our example proof and see, because they had the midpoint. Okay. And I'm looking at statement 4 in my example, and it says A is the midpoint of CE, given. That's very similar to our statement 7. C is the midpoint of BD, given. So now let's look at the next one. A bisects CE. That's similar to our statement 8. C bisects BD. Their reason was the definition of midpoint. So in our blank, we know then that it will be our definition of midpoint. So click on definition of midpoint. And there is your help for lesson 9.